Thank you everyone for joining. Today's webinar topic is effectively tackling hard-coded secrets with a secrets management maturity model. So today's speakers, my name is Orion Casetto. I'm Director of Product Marketing here at Hardcoded. I've got about 15 years, a little bit more than that, of experience in the cybersecurity industry. A lot of that at AppSec companies like Imperva, others in cybersecurity companies, SIM, and some other spaces. I've been a security enthusiast for a long time and definitely excited and interested in today's topic. With me today is Julie Peterson. Julie, you want to give us a quick intro?
Yeah, I am a Senior Product Marketing Manager here at Hardcoded, and I'm excited to talk about hard-coded secrets. I have been working in tech for longer than I care to admit, and I've spent the last dozen or so years writing and talking about security, open source, big data, AI, ML, and lots of other great things. Past employers include White Source Software, IBM, and IDC.
Cool, wonderful. All right, so today's agenda. First, we'll go through kind of an overview of hard-coded secrets, and the goal here is to just, level set for everybody who's in attendees. I'm sure that knowledge on the subject ranges quite dramatically, so this will just be level setting. We'll talk a little bit about some major secrets related incidents that have been in the news. For each of those, we'll try to tie that back to a takeaway that we can use as we start to talk about our maturity model. Then we'll go through a maturity model that we've put together for hard-coded secrets that can help you to essentially identify where your program is at from a maturity standpoint, and to provide some actionable next steps to progress that program in a logical and efficient manner. After that, we will go into the capabilities that you will need in order to make that maturity model or your secrets program come to fruition. After that, we will tie things up with a Q&A, and I just want to remind everybody at any point during the presentation, feel free to use the Q&A box. And we will try to do our best to get to those questions. Also, we will be recording this webinar, so it'll be available for you after the fact if you want to come back and check out anything that we've said. There are a couple of handouts there with additional information about some of the topics we've talked about, and we'll do some polls along the way and see how everybody feels about various secrets-related subjects. With that all said, we're going to move into our first subject, which is hard-coded secrets, and I'll hand things over to Julie. Julie, you want to take it away?
Yeah, I'm very excited to take it away. So we're just going to first start with, a quick overview. What do we mean by hard-coded secrets? Basically any kind of digital credential, sometimes called an embedded credential, that you use to communicate. We see most of them around authentication. So think username and passwords or authentication tokens. Services need to talk to each other, so API keys fall under this category. And then, of course, there's encryption-related credentials, certificates, and encryption keys. And then more and more, we're seeing a lot of custom authentication needs. So things like, maybe an ID number. One of the common things that we see in the retail sector, for example, it's not necessarily authentication related, but something that you wouldn't want somebody to see are things like discount codes or activation codes. So again, in and of itself isn't necessarily a secret, but you don't want getting out there in the wild. ID numbers are another example. They might not necessarily be sensitive on their own, but combined with some insider knowledge, they might be used to expand an attack. And then more and more, we're seeing GitHub used as a non-code storage, so sort of like a Dropbox. And so you have to, as an organization, be aware of what your developers might be storing that's not actually code, and whether that has any sensitive data in it that you don't want exposed. So why are secrets increasing? Well, more and more things need to be authenticated. So the way in which we develop our applications has changed dramatically over the last few years. And we now rely on a lot more SaaS and third-party services, all of which need authentication. Microservices architecture, right, when you're breaking things down into smaller and smaller chunks, these I think containers, right? They need to communicate with each other, and that all requires authentication. And then, when it comes to things like infrastructure as code, you have these microservices, these containers being deployed, calling on infrastructure as code, and that needs to log into perhaps a big database somewhere to get your infrastructure out there. And historically, the alternatives to hard coding secrets haven't been all that efficient or good, and it requires a significant change in developer behavior. So we see some pushback there, right? Developers have to change the way in which they write code in using other tools, and we all know change is hard. So secrets are increasing. Why are they a problem? Well, the issue here is if an attacker can find a secret, they can log in using actual credentials and move into different systems. If they find secrets inside, once they've infiltrated, they can move laterally much more easily using real life credentials, which are harder to detect. And we are seeing with a lot of attacks, and we'll talk about a few of them in a few minutes, but we're seeing a lot more attacks where people are sitting in systems for much longer without being detected. And lateral movement is a huge problem, right? You can get into one system. The way our pipelines are interconnected, you can move left into source code, you can move right into production systems, and certainly it opens up a lot more possibilities for damage being done. Secrets are also a problem for compliance issues. If you think of something like separation of duties, something that, like, say, a Sarbanes-Oxley compliance audit is big on. If you have somebody who's writing source code and they can find a hard-coded secret that is, a database login, then that right there effectively eliminates separation of duties. Now, the truth is we're not seeing a lot of auditors asking questions about this type of compliance violation right now. But as it becomes more and more of an issue, we anticipate that auditors are going to start looking at this as a serious issue. And you will, maybe not this time around, but next time or the time after that, have questions about separation of duties and things like that. And then finally, when you hard code secrets, you're making this assumption that only the people looking at your source code are trusted people. And there's a number of problems with that assumption. First of all, we are seeing that attackers' accounts are being targeted, right? You look back at the sawfish attacks, the phishing attacks from 2020, really sophisticated attacks that were specifically going after developers' accounts. Why? Because developers, once you get in, you can find a lot of great things, including hard-coded secrets. And that allows you to move into other systems. One of the other things that we see is that a lot of code is leaking, and a lot of it is inadvertent, right? So the way that Git systems are designed, you have developers bringing their own account into your organization. And if they're working on proprietary code and they accidentally save it to their personal repo, and oh, by the way, that personal repo is set to public, well, then all of a sudden you have a code leak. If you have a hard-coded secret in there, you're just increasing, not only is your IP exposed, but you're giving away even more and more sensitive data. And then finally, you have to worry about malicious insiders. If you have hard-coded secrets and you have somebody who wants to do some damage and they can have access to those secrets, it opens up a whole range of activity beyond just like their little corner of the world. And one of the things that has recently been a trend with sort of the Great Resignation is a lot more developers are leaving organizations. And there's been a study done recently that shows that with the amount of turnover in the developer organization, more developers are taking code with them. And it's sort of tripled over the last few years. And when they're taking code with them, if you have a hard-coded secret in there, you are, again, increasing your risk. So secrets, I think we can all agree, are a problem. Right? So the bottom line here is if you have secrets in code, you have to assume that at some point your code is going to be leaked and that those secrets could be exposed. So this image here is GitHub's Digital Millennium Copyright Act takedown notices over the last few years. And you can see that the trend line is that, you know, it's more than 10 times what it was from just 2015. And one thing to note here is that a takedown notice can actually encompass many repositories. It's not a one-for-one. So if you're an organization and you've had 10,000 repository leaks, you might only just have one takedown notice. So again, the problem is probably even more severe than it looks like on this chart. And so code is being leaked. And if you have secrets in code, they're going to be made public. So again, you have to just assume that at some point your code's going to be leaked and a secret in code is going to be exposed. So from there, I want to talk a little bit about some of the headline grabbing incidents that we've had of late. We're going to start with everybody's favorite breach, SolarWinds. So, you know, we've all seen the headlines. We know SolarWinds was the victim of a really sophisticated nation state attack. And if something like Cozy Bear is going to go after you, you know, you're going to be pretty hard pressed to prevent a breach, unfortunately, right? They've got a lot of power going after them. And we know that SolarWinds was breached via a TeamCity server. But it was also discovered at the same time that SolarWinds was leaking secrets via an FTP server. And it is surmised that the way in which SolarWinds was so thoroughly compromised and that the attackers, you know, stayed in their systems for so long that secrets played a significant role in expanding the attack. So not only did SolarWinds, you know, themselves get breached, but as most supply chain attacks, right, it was about accessing their more than 300,000 downstream customers. And one of them was or is Microsoft. And Microsoft, you know, got hit by the SolarWinds attack. They were breached. And what they found, you know, afterwards, when they started looking around in their code, was that they noticed the attackers were specifically searching their source code for hard-coded secrets. And, you know, Microsoft was one of the lucky ones. They said that they didn't have any hard-coded secrets, so none of them were actually exposed. But this just goes to show you that secrets are a high-value target. So they were used to expand the breach in SolarWinds itself. And then for their downstream customers, secrets were the main target. So this just shows you really how valuable attackers believe these hard-coded secrets are. And then Orion, I think you have another example coming up next.
I do. It comes from the state of New York's Office of IT. Essentially what they had was a GitLab misconfiguration that led to a secrets leak. And you know how it essentially unfolded was the state of New York's GitLab instance was configured in such a way that anyone from the internet could simply log in or create an account, log in, give themselves admin privileges, and then access the entirety of the content. So all the repos, all the projects, etc. Some of those were production systems. Many of them had hard-coded secrets. And, you know, essentially, I think the main takeaway here and one of the things that I guess we'll come back to is essentially that like hard-coded secrets can happen and exposure can happen very easily by minor configurations that are elsewhere in your software delivery pipeline. You know, it could be a misconfigured S3 bucket. It could be something like this, which is, you know, simply just a misconfigured SCM, a source control management system. But, you know, it can happen very easily. And that is one of the reasons why, you know, you really need to remove them from your systems and environments, because you never know how the exposure could come about. Julie, back over to you.
Great, yeah. So another high-profile breach was Code Cove, and secrets played a huge role here in a number of different ways. So first, the attackers infiltrated Code Cove by finding a secret in a Docker image. Okay, and they used that secret to then log into Code Cove and alter their bash uploader script. And what they did was they altered the code so that when downstream customers access that, instead of sending get credentials back to CodeCove, it was sending it to the attacker's server. So the attackers were able to mine those credentials and then log directly into the downstream customers' Git systems. And then what they were doing was mining them for secrets. So secrets were used sort of all around to, initiate attack, expand the attack, get to downstream customers, and a lot of, high-profile companies, Twilio, Monday, Macari, and more were impacted. I think HashiCorp as well, were impacted by this, and it was all about the secrets.
Yeah, super interesting. Another kind of high-profile one comes to us by way of Amazon. This one's interesting for a couple of reasons. So essentially what happened here is an Amazon Web Services engineer inadvertently leaked inadvertently leaked information to the public. It was about 1 gig of information. It had some of their own personal information, but it also had some secrets that included credentials that provided access into AWS web environments. Now, there's, I think, 2 really noteworthy things about this. The first is that, it's Amazon, right? And if this could happen to a company like Amazon, who's, tends to be at the forefront of a lot of things, kind of in the cloud and digital world, it could happen to a lot of other organizations that maybe invest less in security. The second real takeaway, it comes down to how long it took for those credentials to be discovered. What ended up happening is that, the information was leaked out into the wild with the secrets, and somebody within a matter of a mere few minutes actually reached out to Amazon and told them that this was happening so that they could rectify the situation. But, I think the takeaway is that could have just as easily been an attacker as it was, the benevolent party that notified them of their leak. And it happened in just a couple of minutes. And so the takeaway, and what we'll bring back to this conversation as we move forward, is really it is important to be able to handle these sorts of things quickly. So if you end up with an exposure where your code is out in the wild, 1, it shouldn't have hard-coded secrets in it in an ideal world. But 2, you need to be able to handle the situation very quickly in order to minimize the chances of an attacker finding your secrets. With that said, we're going to transition our talk a little bit. We've got a poll, so if everybody can head over to their GoToMeeting control panel, I'm going to launch the poll right now, and we'll see what you guys think. So the question is, what causes you to lose the most sleep about hard-coded secrets? We'll give everybody a little bit of time to answer. Here I'm launching the poll now, so in theory, everyone should have an opportunity to vote. So go ahead and head there now. The answers are exposure via source code leaks, which is what we just talked about with Amazon, exacerbating existing attacks, so kind of the idea of lateral movement that Julie was talking about earlier, compromised insider accounts, so attackers stealing credentials and then gaining access to maybe code that has credentials in it, malicious insiders, so people abusing their privileges, and then finally compliance violations. An example of that being what Julie said earlier, which is maybe separation of duties, somebody, a developer who now has access to a database. So we'll give you guys just a little bit more time. Looks like we're almost at critical mass here. Give you another 10 or so seconds, and then we'll see what everyone says. All right, closing the poll now. So let's share the results and see where we're at. So in theory, hopefully everyone can see this. It looks like the #1 thing that causes people a lack of sleep, or the #1 thing that you're caring about, is code leaks. After that, compromised insiders, malicious insiders, and exacerbating attacks. So that lines up with what we've heard when we've talked to many organizations. The good news here is that we will provide some very actionable guidance for everybody on the call in terms of how you can reduce this exposure and some very pragmatic steps you can take. I'm going to close that poll and we'll keep moving forward. All right, back to our regularly scheduled programming. So we're going to shift gears at this point. We're going to start talking about the maturity model. So over the next several slides, we will walk you through a model you can use to identify where your program is at and what you can do to take it to the next level. So at the highest possible level, the maturity model looks like this. We have 5 levels that range from the least mature, which is level 1 awareness, and it moves up to the most mature, which is a risk reduction approach. And so step by step, we'll go through these, starting at awareness and going up the model. And essentially, you could think about this in a cumulative fashion. So everything at a higher level includes everything below it, and your goal is to get to the top of this pyramid. So with that said, we're going to start at the very bottom at awareness, level 1. So by nature of you being here at this at this webinar, you are probably at least at level 1. Level 1 is essentially an understanding of the problem and how it relates to your environment. So you understand that your applications or your organization's authentication needs are increasing, and that's likely driven by things like microservices, infrastructure as code, APIs, the use of cloud environments and third-party services. And so you have all these new authentication needs, and so your applications need to account for that. So that idea then triggers the thought of like, hey, how are we handling that authentication? And then the idea of hard-coded secrets being in your code. Probably everyone on this call is there at this point. Now, the first step in this is to figure out what to do about that. And usually it begins with training for developers on how to avoid hard-coded secrets, and then maybe putting some policies in place to address the issue. Just at a policy level, I want to be very clear. At level 1, we're not doing any scanning. We're not doing any detection. There are no hard enforcement mechanisms. I'll give you an anecdote of a customer, not ours, but an organization that we talked to that kind of epitomizes a level 1 organization, just to give you an idea. So essentially, they knew hard-coded secrets were a problem, and how they decided to deal with it was to fine developers $50 if there's a hard-coded secret in their code when they merge it into the main branch. Now, there's a whole bunch of things wrong with that from a security standpoint. One, it doesn't really stop the problem. You're still introducing hard-coded secrets into your code base. 2, you have no idea how many exist from this happening in the past, so you're not finding anything in your version histories. You're not looking more broadly across your SDLC. 3, $50 is a lot of money, but to some people it's not a lot of money, and it may not be a motivating factor if somebody is feeling lazy or otherwise motivated to just skirt the rule. There's a whole bunch of things wrong with this. It's less than a proverbial band-aid, right? And so it's an example of what someone might do at this level that is not best practices. So what do you do about it? Well, you can move on from awareness up into a higher level, and one of the most basic things you can do is to start scanning for secrets. So when you get into level 2, basic detection, essentially you're looking for a tool or building your own using an open source tool that's going to look for secrets in your environment. And typically at a level 2 organization, this effort is almost exclusively focused on your source control management system. Looking at your, hopefully all of your repos, but at the very least, the ones that are involved in developing, your production code. It should ideally, and often does at this point, look into your version histories of those repos to make sure you may have exposed a secret in the past. It's no longer there, but it may still be findable. Here, we are looking typically for common secret types, API keys, passwords, authentication tokens. Now, it's important to know that at this level, most organizations are running these scans in an ad hoc basis. So someone says, hey, it's been a while, I'm going to kick this off, or on a time basis, whether that time is, hourly, daily, weekly, monthly, the more often the better. But those are kind of the 2 ways that these scans are getting triggered. So we're making a little bit of progress. Probably if you're on this call and you have started to tackle secrets management, you're probably at least at this level, maybe not. Okay, now things start to get more interesting when we get into level 3. Level 3 essentially takes the idea of detection or scanning and it improves on it, and breadth, depth, and fidelity or prioritization. What I really mean by that is we're going to be looking for secrets in more places, because secrets can exist in many more places other than just your SCM and in your code. They can exist throughout your entire SDLC. They can be in infrastructure as code. They can be in personal repos and public repos. They can be in build logs. They can be in containers. They can be in cloud environments. And so really what you need to do is to scan the entire gamut of your SDLC. Two, you need to start looking for more types of secrets. So that could include, authentication certs. It can include custom secrets, like Julia was talking about earlier. So that might be, ID codes, discount codes, something that's very specific to your business or your application. You're going to want to start to look for those. And then finally, now you're going to start at level 3 to begin to include the idea of prioritization. So here we're going to say, all right, well, we have a giant list of secrets. We need to figure out which of these secrets are the most impactful and start at the very top of that list so that our developers are tackling, those that pose the highest risk to the organization first. Here, you're going to want to be pulling in data about not only the secret, but the environment and the usage of the environment from the entire SDLC. So you have the context to make, interesting, impactful or accurate decisions. Here, it's things like, what type of secret is it? Who has access to it? Where is the secret? Is it test or production environment? Things like that. And ideally, we'll provide you some actionable ways that you can do that, but that's the capability. Things get much more interesting when we move into level 4, when we start talking about enforcement and alternatives. We're going to talk about these separately. First, we'll talk about enforcement, and then we'll talk about alternatives. So enforcement here, what we're talking about is taking the idea of scanning and taking the idea of remediation and bringing it directly into the developers so that you can say, all right, well, we have a secret management policy. Now we're going to start checking that you're adhering to it. And how this typically works is through developer workflow integration. One common way to do this is to integrate with SCMs, and essentially, if you're looking up here at the top of this this diagram, what you're looking at is an illustration of kind of a pull request. So you've got your main branch here, we've got our feature branch here where our developers are working, and you're going to start scanning at pre-commits and at pull requests. And when essentially what you're looking for is hard-coded secrets. If you find a hard-coded secret, you need to provide the information around that secret, where it is, what it is, to your developer, and some fix suggestions. You can also take it one step further and do the same thing at the pull request. And here you have the ability to, if your organization has the appetite to do it, to block unfailed tests, to say, hey, look, if there's a hard-coded secret in this code, we do not want to allow it to merge into the main branch. And that essentially kind of sanitizes your main branch and keeps, keeps the secrets out. Then if the developer fixes the situation, resubmits the pull request, then you can have it go through because there's no hard-coded secret. Essentially what you're doing is preventing secrets from entering into your main branch. Now, the kind of 1-2 punch here is if you're going to, take a hard approach towards enforcement for these policies, then it is best to provide your developers with an alternative to hard-coding secrets, and that'll help them to comply with your policies. So here, the idea is to adopt a secrets management tool. Now, I'll walk you through this, but the thing to be thinking about is we're going to treat secrets with a tool like this in kind of the same way that password managers work, or people who are familiar with a privileged activity monitoring tool like a CyberArk. It's the same general idea. What you're going to do is you're going to use a secrets management tool like HashiCorp's Vault, for example, and your developers now will have the ability essentially to program their applications to reach out to the Vault whenever they need credentials or a secret to access a resource. So then the secrets manager is going to provide the application with that secret. That secret can be used to access the resource. And essentially, this is an alternative to the idea of hard-coding a secret. You're essentially hard-coding this call instead of hard-coding the secret. There are some benefits here. One of them is if you find that a secret has been burned, it's been exposed somehow, you can easily rotate it at the secrets manager. This makes it very easy for you to, you don't have to go back to the code and change anything. You just, change it at the centralized point. So this becomes a very powerful combination. On one hand, you're preventing your developers from, hard coding by scanning directly in their commits and pull requests, and you're providing them an alternative. If you didn't have one or the other of these, it would be hard to be impactful. Like if you just had, a secret management tool and not the enforcement mechanism, people could bypass it. Or maybe they're new and they don't know that they need to use the tool. If you just have the scanning, but you don't have an alternative, then people may not follow that policy. All right. Now, at this point, you have a fairly effective, at level 4, you should have a fairly effective secrets management program. And to kick it up to the highest possible level, you need to take several steps back, view things more holistically, and say, okay, for the problem of hard-coded secrets, how could I reduce the risk? Well, the risk is a combination of the threat and the exposure. So it's a combination of hard-coded secrets and those hard-coded secrets, being exposed to an attacker. And there are 3 main ways that that happens. Through code leaks, which was a main concern of everyone on the poll. It can happen through compromised accounts and malicious insiders, which were actually number 2 and 3 on the poll that we just did. So what we need to do is find ways that we can reduce the exposure risk on the right and thus reduce the risk that secrets pose our organization. And there are some things that you can do here by implementing essentially complementary security techniques that you maybe are doing elsewhere in your SDL security program. So let's talk about compromised accounts first. The idea here, the problem here, is that you have attackers, they're stealing a credential, using that credential, ideally a developer's credential, to gain access to whatever the developer has access to, so like a code base. And they're looking for hard-coded secrets in it. If you can break that attack chain, then you make it much harder for attackers. And how you would do that, first and foremost, we want to make it harder to compromise the account. So you need to make sure that you have strong authentication, like multi-factor authentication, in place. That makes it so it's harder to compromise that account. Secondly, you need to essentially implement and make sure it's up to date the idea of least privilege. So reducing access and privileges in your SCM and your other tools across your SDLC to only the things that are required to do your day-to-day job. In doing so, essentially what you're doing is you're forcing attackers to not only compromise an account, but to compromise the right account that has access to the right code base that actually has a hard-coded secret in it. So you're just, it's the defense in depth, it's the onion idea. You're making it just that much harder, and you're putting more barriers in front of the attacker. Some of those same concepts actually work for malicious insiders, very specifically the idea of least privilege. So, you have a developer. Oftentimes, developer accounts are very over-provisioned because they have, the idea is give them access to everything, so in case they need to do it for their job, they can do it efficiently. But by implementing least privilege, you're reducing that developer access to the things they need to do their job, which means, if they're going to abuse their access privileges, they may not, because you've trimmed their access, they may not have access to the code base that had a hard-coded secret in it. You're just, again, shrinking your exposure surface. On the code leakage side, this is a main concern for a lot of people on the call, something like 60% of you. So the problem here is if your code gets, inadvertently leaked out into the outside world and it had hard-coded secrets in it, then boom, attacker finds it and they can get into your environment. Very, very real concern. There are some things that you can do here from a security and governance standpoint and from a scanning standpoint that will help deal with this. On the security and governance standpoint, what you want to do is to implement, proper configurations across your entire SDLC, but also very chiefly in your SCM to reduce the likelihood of a code leak happening. A perfect example is the state of New York's IT office, right? They had a misconfigured Git instance. Anyone could just log in, anyone could access their stuff. Like that is a configuration issue that can be found programmatically and can be addressed programmatically, right? And so implementing strong security and governance can deal with some of the prevention. Then the other thing that you need to do is if your code is out in the wild, you need to find it quickly. And here there are scanners that essentially can help you to fingerprint your code and to scan public sharing sites for your code for signs that it matches those fingerprints, and then to alert you so that you can very quickly take it down. So it's kind of a combination of a little bit of preventative measures and a little bit of after the fact detection, and this can greatly reduce your risk. And so I think the point here, the point of level 5, the big takeaway is there are other things that you can do that are complementary from a security standpoint to hard-coded secrets that can really, really, kind of turbocharge your hard-coded secrets program. All right, that was a lot. So we're going to take a quick break by doing a poll before we talk about what capabilities you need and how you can find them. So our next poll, I'm going to go ahead and get it launched. So everybody head over to your control panel. The poll should be coming up in just a second here. Open it up now. Okay, so the poll is, what is your organization's biggest unmet need for hard-coded secrets? The first one is, we have basic secrets detection, or we have no secrets detection, or we are just starting our program. So, the problem here is just that you're not doing anything or very low. Number two, scanning for secrets across the whole SDLC. So you're not doing that. You're only looking at the SCM, so kind of a narrow focus. Number three is you have too many false positives or negatives. So that makes remediation very difficult. Like, how do you prioritize your results? Number four is lack of developer buy-in. So here you might have a process that's clunky or burdensome or difficult for your developers. And so, hey, they don't want to get with the program. And number four is overemphasis on finding secrets versus risk reduction. This is the idea of, essentially that I just talked about, using complementary security techniques to reduce your overall risk. Give you another 10 seconds or so, then we'll go over the results. Okay, closing the poll now, and we'll see what everybody said. All right, so 37%, the largest chunk said, hey, we're in a basic secrets detection mode. We have nothing, or we're just starting a program. We actually hear this an awful lot. This is kind of the state of where a lot of people in the organization, in the industry are. This is like something over the last couple of years that people are really tuning into and trying to tackle with current budgets. Scanning for secrets across the whole SDLC is difficult. That's an absolute other one. So going back to my maturity model, that's like moving from a level 2 to a level 3. Too many false positives, again, that's an issue. People don't have the context they need to do a really good job. And then lack of developer buy-in. So all very, very good answers. All right, so we'll get back to our program here. Okay. So we're going to hand things over to Julie, who's going to kick us off. This next section is about secrets management capabilities. So if you wanted to implement an effective program, what capabilities do you need? Julie, over to you.
Right. So we want to help you get from level 1 or 2 or wherever you are up to that level 5. So the first thing you need to do that is to have scanning capabilities, and you want a number of complementary approaches so that you can detect all secrets and all of their incarnations. So you need a tool that can scan for known patterns, right? So something like a Google API key follows a pattern that we know. And when you know the pattern, this is going to be the most accurate way in which to detect secrets. And another complementary approach is to search for high entry strings, which may indicate that you do have a secret in place. The downside of searching this way is that there can be a high number of false positives. And then finally, you want a way to look for how your application is built and any specific usage of secrets that your application uses. So once you have scanned your entire SDLC for secrets, one of the things that you need to do is improve your results, right? We want to cut down on noise whenever possible. And so a good tool is going to allow you to have your developers report any false positives and within a certain context. So, you want to report a false positive across the board, or just in this instance, you need to be able to enrich your scan results with real life experience. And then finally, you need to correlate your secrets across every stage of your DevOps pipeline, including code, build, artifact, and production. Why do you need to do that? Well, it helps you prioritize. And back to you, Orion, talking a little bit about prioritization.
Yeah, absolutely. So prioritization is a huge thing. So essentially, all of this is things that you should be looking for when you're looking for tools that could help you with your secrets management program. I think the key here for prioritization is really getting information from your entire environment and then being able to make it actionable. I guess before I get into the specifics of the slide here, one of the things that can be very useful for this is a solution that has kind of a graph database backend, because it can essentially pull in data from all over your entire software delivery pipeline, your DevOps tools, your infrastructure, your build servers, etc. And to correlate that information to have useful insights. That could be things like access patterns, usage. It could be things like, where is the secret used? Is it in test or production? How critical is the resource that's being protected? Is it an API? Is it a S3 bucket? Is it customer information? Is it PHI? Is it PII? Like, what's in there? How likely is exposure? So how many people actually have access to this resource, and which people are they? What are their roles? How strong is your identity model? Things like least privilege. How often are you able to audit for excess privileges? How strong is your authentication model? A lot of these, this information exists within your DevOps environment, within your SDLC environment, and it just, if you can bring it to bear onto the idea of a secret, you now are able to take a list of hundreds or thousands of secrets and say, like, based on all of this criteria, these are the highest risk ones that we need to handle first. And you can kind of point your development efforts in that direction, or your remediation efforts. Julie, you want to tell us a little bit about workflow?
Sure. So when you're addressing the problem of hard-coded secrets, one of the things that you really need to think about is the human factor, right? We've talked, about organizations and the maturity model that don't have developer buy-in, right? So you can have the tools in place, but if the developers aren't using it, you're not solving your problem. And so we feel that the best tools actually provide information to the developers when they ask for it. So give it to them in their environment at the right time before a merge request is complete. And if you look at this image here, this is an image of GitHub, and it shows that developers are doing a scan for hard-coded secrets, and they're being given results right in GitHub itself. So there's no context switching, and we are preventing secrets from even hitting the main branch, your main code branch. So again, you're giving developers information when they ask for it in the right context without having them switch. And if you're meeting them where they are, where they live and breathe every day, you're more likely to have them adopt the tool. And there are a number of other workflow suggestions. They include things like pre-commit hooks, pull request integrations, alerting on finding a secret, integrating with your existing ticketing systems, and then also confirming that fixes have been successful. So that you have this confirmation that new scans are showing you that, yeah, that secret no longer exists. So again, address the human factor, give them tools that work where they work.
Yep, I like it. The last little bit, and we talked about this earlier, is kind of the 1-2 punch. This is absolutely not something that we do. We don't have a secrets management tool, but it is a very important part of your program. Essentially, it's what Julie just said. So meet the developer where they are, give them the tools to be successful, put enforcement mechanisms there, but give them an alternative so that they can be successful and they can adopt to your policies. And one of the ways that we suggest doing that is through the secrets management tool. These are available from a number of different places. One of the places that you can get one is from infrastructure providers. So, the AWS and Googles of the world. There are a number of companies like Vault and Achilles that have their own solutions. And then, as I said earlier, some of the PAM players are moving into this space like CyberArk. But, again, the idea is just allow your apps or your developers to program your apps or to code your apps to reach out to the secret manager when they need a secret. Then it provides that secret, which then provides access to the resource as needed. So this is a very powerful 1-2 punch. Kind of a session summary. So this would be a great time to start typing questions if you have them. But in wrap up, what we've talked about today is secrets are a large and growing problem. They're being driven essentially by architectural changes like the increased use of IAC, microservices, cloud and SaaS products. It's absolutely possible to put together or to use a maturity model to provide a practical path forward in terms of, looking for capabilities and implementing capabilities to go from essentially nothing or nascent or a basic state up into, a really advanced state, and then an optimized state where you're thinking more broadly across your entire SDLC and security programs. Effective secrets management program needs, you essentially need a tool that can help you do some of this stuff, right? And whether that's, a homegrown tool, whether that's an open source tool, whether that's a commercial tool. We talked about some of the main categories of capabilities you need. You need to be able to scan for secrets. You need to be able to prioritize the results so that you can, be efficient with your remediation efforts. You need the ability to meet developers where they are. So bringing the results of that and that scanning directly into their workflows and give them the information they need to be effective. And you need a secrets management tool in order to provide a good alternative to all of the above. Then to get to the highest level here, it is important to take into account how you can influence your hard-coded secrets initiative by way of complementary security initiatives. Specifically, you want to close exposure. Some of the ways you can do that is you can implement effective security and governance to deal with malicious and compromised insiders. That's things like, strong authentication and least privilege policies. And then to prevent and detect code leaks to minimize attacker exposure. So, again, it's, changing the configurations of your SCM and other tools to make it harder to leak code. And then on the other side, scanning, fingerprinting your code base and scanning out in the wild to make sure that you can pull, be alerted to and pull down your source code from public places as quickly as possible. With that, one last slide and we'll get into our Q&A. So I just want to thank everybody for coming. So Hardcoded is a complete software supply chain security solution. We provide you with visibility, security and governance, and integrity across your entire SDLC. There are a number of use cases that kind of fall out of that, including security and governance for your CI/CD pipelines, code tampering prevention, hard-coded secrets, which is obviously the topic of today's conversation, code leakage, IAC security, software composition analysis, and security and compliance assurance. With that, feel free to go ahead and put things into the Q&A box and we'll start addressing everybody's questions. I can see that there are several of them coming in already.
Oh, that's great.
Yeah, so since you've just spoke up, Julie, why don't you take the first one, which is,
okay.
We use HashiCorp Vault. Do we still need to scan?
Oh, that's a great question.
Yeah.
yeah. I mean, right. Having a secrets manager is great, but yes, you do still need to scan. So, first of all, you need to know whether there's any existing secrets in code, left over. And, not only the SEM, but elsewhere in the SDLC, right? So think about, Code Cove, where there was a secret found in their Docker image, right? So you need to scan the whole kit and caboodle, as they say. So yes, you do still need to scan. Anything else you want to add to that, Orion?
No, I mean, I think that's it. And I think it answers the next question. Oh, well, actually, the next question that came in is very complimentary. So no, I don't have anything to add to that. The next question that came in is, does Hardcoded integrate with secret management solutions like HashiCorp Vault? Currently, we do not. We have had feature requests to do exactly that. So it may be something we look into in the future, but right now we don't. We have talked to the people there and they are very, they work well in parallel, but they don't talk to each other today. Okay. Julie, here's another one that I think might be interesting for you. Who owns the hard-coded secret problem?
Everyone. No, that's the short answer. I mean, I think, well, first of all, it's a big problem. It touches a lot of tools. Clearly, security owns it, right? Because the hard-coded secrets just represents such a huge risk to the organization. So, security is in there. But, developers are the ones who are creating these hard-coded secrets, right? So engineering, development, what have you, they actually have to be part of the solution, right? So they need to be working with security on solving this issue. And, then we think about like all of the different tooling that you need to scan through, that definitely could bring DevOps into the equation. So I think, yeah, I'm going to go with my short answer of everyone. Everyone owns it.
I like that.
Sorry, that wasn't like maybe the answer people wanted, but that's the answer I have. So I don't know. Anything you want to add to that?
No, it makes sense. I mean, it has to be a joint responsibility, right? Security owns the security part. Hardcoded secrets have an implication there.
Yeah.
Development owns development. I'm great with that.
Yeah.
The next one, and I'll take a stab at this one. How does Psycode compare to open source tools like TroubleHog? I mean, so here the first way I would suggest that they're very different is, TroubleHog's great. It's an open source tool. It is great for scanning in your SCM. There are things outside of your SCM, your build logs, your container registries, your cloud environments, your IAC that are maybe outside of the scope of TroubleHog. So I think that is, the first major difference, and it is very important to make sure that you scan, the entire SCLC. We had a couple of examples in our incidents section. AWS. Well, we had a couple of examples of secrets elsewhere, but I mean, it's very common to hear of secrets, being in S3 buckets and things like that. So that's the first way. The second way is, I would say, Psycode does a lot of the complementary stuff that we were talking about earlier. So, our security and governance can help by clock down the tools themselves. We have code leakage scanning. We have, IAC scanning. There's just so much that can be done to address the problem of secrets and be more effective with your secrets program by tackling other adjacent SDLC security issues or software supply chain security issues. And you don't get any of that with TroubleHog. So, they would be very good at scanning your SCM. So it's definitely a step. It puts you to probably level 2 in the model.
Yeah, I just want to reiterate that I think code leakage was the top concern when we asked, what are your big concerns with secrets, and code leakage was up there, and it's not something TroubleHog even addresses, right? Whereas, that's one of those complementary solutions that we can help you with. And if your code isn't being leaked, then your exposure is already not automatically reduced.
Yeah. Okay, so we've got a couple coming in that kind of have the same theme. So I'm going to read one of them, and hopefully everyone else, this is helpful if you had kind of a permutation question to this. Okay, you mentioned complementary security activities. So I just talked about that. Strong authentication, least privilege, helping reduce the risk of hard-coded secrets. Can't I just use GitHub to do this? And I guess, Julie, I don't know if you want to take the first stab on this, but I assume what they're talking about here is GitHub advanced security as opposed to just GitHub generally.
Yeah, you're right. I think, I would assume that too. I think GitHub is certainly useful for managing some of the security and governance, right? But you have to remember that that's just for GitHub itself. It doesn't look at any other parts of your SDLC. And you've got all of these tools and they're all tightly integrated. So you need strong security across the board, and GitHub can't help you with, like your CI/CD servers. The other thing too is I think, it's unclear like what happens if you have multiple instances of GitHub. How do you manage that if you're looking at, multiple?
Absolutely, I totally agree. And if, for example, it's not like GitHub is going to go tune Amazon Web Services and make sure that you have strong authentication or that you have, least privilege in place. And so, there's just not a mechanism for that. And so, GitHub Advanced Security definitely has its place. I wouldn't suggest it's necessarily good for security and governance. And, tacking on to that, part of the story is code leakage. And, I don't want to leave that out either. It's not like, GitHub is scanning all the, fingerprinting your code in your repos and looking on other sharing sites for it. Okay, here's one. Is there a way to enforce local pre-committing for all of our developers? That is coming. It's not something we support today, but it's coming in the incredibly near future. So hold tight on that one. The answer will be yes. It's not quite there yet. I'm not going to give you a time because our PMs would kill me, but
no, not at all.
No commitments, no commitments. Okay. Where do you think most organizations are on the secrets maturity model? I guess, I'm happy to take a first stab at that because
Yeah, I think this is a good question for you, for sure.
Cool. Yeah. All right. So I would say if I busted this out into a couple of different categories, I would say like, first off, we did a poll here, and I would say most of everybody that answered the poll is probably like in a level 2 or 3. But I would say like if you're DIYing this and you're trying to like build something yourself or like use an open source product like TruffleHog, you're probably like in the 2s and maybe trending towards a 3. Most of your scanning is probably in the SCM. If you're doing a good job and thinking really holistically, you might have a secrets management tool in place with that, and so you might have a little bit aspects from a 2 and a little bit aspects from a 4. So maybe I'll give you like a 2.9 or 3.1 or something. But to buy a commercial off-the-shelf tool, you're probably like a 3 or 4, depending on what tool you've purchased and whether you have a secrets management solution in place. To be very, very honest, 5s are pretty rare because it not only makes to be a 5, you have to be thinking about very holistically about your entire software supply chain security program, but you also need to have all those tools in place. And calling it what it is, software supply chain security or SDLC security, a lot of the concepts and tools are very new, and people might have some of them, but they're not all working in unison in concert. So I would, short answer, probably mostly 2s and 3s with some 4s. Okay. Answered that one. If you don't block a merge that has a hard-coded secret in it, so like, some organizations, maybe this is my own commentary, some organizations maybe are never cool with that. The rest of the question is, what is the workflow for remediating it? And this will probably be our last question because we have 2 minutes left. So just to repeat, if you don't block a merge request that has a hard-coded secret in it, what is the workflow for remediating it like? Julie, do you want to take a stab at that?
Okay, right. Yeah, definitely. So if it's not your policy to block a pull request with a hard-coded secret in it, I think some of the things you could do is you could still set up like a workflow where it creates a ticket and notifies security or whoever the responsible party is. I think a good solution here is to use a workflow engine to automate this. So when it's found, it automatically opens a ticket and notifies key stakeholder. We're not just ignoring it. We're not just saying, hey, we know it's here and forgetting about it. It gives security or whoever is responsible an opportunity to fix it, remediate it.
Yeah, think mini SOAR, right? If this happens, then pick up this workflow. Absolutely.
Sounds good. Great.
Cool. Well, it was great to talk about this subject with you, Julie. Thank you for your time. And it was awesome to see so many questions. Clearly, people are engaged, and this is a subject people care about. So thank you to the audience. So a couple of just quick reminders as we part ways. So there are several handouts here if you want to learn more about our solutions. There's also a white paper by EMA, Enterprise Management Associates, which is an analyst firm that talks about similar concepts about how to build a maturity model and how to put together a secrets management program. And then this recording will be available within the next 24 hours. We'll email it out. And thank you, everyone, for your time.
Yeah, thanks for the great questions. Appreciate it.
Bye-bye.